Hi everyone, this is the first example of chapter 9.4. It is question 207. Let's read the question. Question 207. If a hydrogen atom in the ground state absorbs a 93.96 nanometer photon, A, how does this affect the atom energy? And B, how much energy is needed to ionize the atom when it is in this excited state? Let's write down the relevant piece of information that we are given. We're given the wavelength of the photon, 93.96 nanometer. We are also told that the electron initially is in the ground state. The ground state means the level is 1. Now in the formula that we will need to use, the value m is the smallest or the lowest level. Well, there's no lower level than the ground state, therefore m has to be 1 in this case. The first step is we want to figure out on which level does the electron end up after absorbing this photon. So we need to know how much energy is in the photon. So the energy of the photon is the Planck constant multiplied by the frequency. We don't have the frequency, but we do have the wavelength, so we make this change, c divided by lambda to get the frequency. And this will be equal to the ionization energy multiplied by that term over here. So first, let's calculate the energy in the photon. Once we compute everything, Planck constant, speed of light, the wavelength, we get 2.116 multiplied by 10 to the power minus 18 joule. Now, it is way more convenient to use the value in electron volt. So we do the conversion and we get 13.22 electron volt. Now we have the value, the energy for the photon, we put it into the formula. We have that formula, one unknown. It's a simple matter of algebra to isolate the n. Here, I get an n of 5.99. It's really close to 6 and n has to be an integer. In other words, it cannot be 5.99, so I round up to 6. And this value is mainly due that I use round-up value for the formula. For example, I use the speed of light 3 multiplied by 10 to the power 8. It is close enough for me, but if you get a value really close to an integer, just round up to the next integer. All right? Now, we are asked, what is the energy level of the electron? What is the energy of the electron? And basically what we just found is that the electron will end up on the 6th level. Now, just to put this into perspective, in the ground state, the electron has an energy with respect to the atom of minus 13.6 electron volt. Minus is just a way to say that this is the energy needed to extract the electron. If we assume that the electron just barely escaped the electric force of the atom, it will have an energy of 0 and will be free to go. So the minus only indicate that the electron is linked to the atom. Now, we do not have the electron on the ground state, we have it on the 6th level. So E6 is equal to minus 13.6 multiplied by 1 divided by 6 squared, and we get minus 0.378 electron volt. So this is the answer for part A, and it is also the answer for part B. In part B, we are asked how much energy is needed to ionize the atom when it is in this excited state. Well, basically, the value you find on the energy level using that formula here will always tell you how much energy is needed to ionize the atom. Basically, to ionize the atom, you need to get to a 0 electron volt. Well, you are minus 0.378 electron volt. That means you need to supply 0.378 electron volt to ionize this atom. All right? So we are going to be solving one last example, which will be the last of this semester. All right, so see you in the next video.